Yeah, you sound good to me, by the way. Oh, it says I can't hear Ben. Hang on. There, no,
It's much lower latency than when I was streaming.
cannot hear Ben. All right, I just turned on your audio. Try now. Can people hear him
Hello.
now?
Yeah, can you guys hear me?
Now we
Now
can.
they can.
Okay.
Perfect.
So, since I upgraded XSplit, I no longer turn off the... Oh, is Ben echoey? Say something, Ben.
Hello, am I echoey? Am I echoey? Woohoo. I like
Perfect, somebody
echo.
says.
I play with echo all the time. Well, with guitar. Maybe not with
Yeah.
my speaking.
Right. Well, remember the old reverbs with the springs in them? I love those things because you could impart your own nonlinearities in a physical way. And
Yeah.
what
we used
were
to
they
whack
called?
the guitar amp.
Yes, you
And
would.
it would go.
Yeah. Yeah, Ben and I were talking earlier. Ben, in addition to being a musician, we both had done lights for rock groups, which I was saying was a great way to meet women because they can walk over and talk to you while the guys are playing on stage. And perhaps I took on a role as a pimp for the drummer, but we'll stop there. It's
And that's why this on YouTube is for 18 and over.
yes, yes.
So
Well, so what do you
No,
want
I
to talk
love
about
doing
today?
lighting.
Oh yeah, I did too. Because you couldn't be out of tune, right? I had an organ keyboard where each key was a different string of lights. Then I even put flash pots way down on the left of the board, so you didn't want to accidentally hit one of those keys.
Oh, so you were doing pyros as well?
I was, yes.
Yeah,
And-
I had a pyro license temporarily in New South Wales to do that. But I only got to do a couple of shows, unfortunately. I wish I could have done that a lot more. That was fun. Pyros is fun.
We used to start with Rock and Roll by Led Zeppelin, and the guys learned that I would set off these big flash pots right after the so they would start backing up right away because the flash pods were in front. So one time I put a big flash pod behind them, set it off, and they're running towards the front, and then I set off the ones in the front, you know. And that's a typical booby trap the Army teaches you, is you set off a mine here and everybody reacts to it, and then you get them.
Well, now, I don't know if you've seen these, but we used to use these gerbs, and they were pyrotechnic devices, and they were like a shower of sparks, right? And you could get a flash pot that was just a big poof, like one.
Right. Black
Or
powder.
you could get
yeah.
gerbs that would go for maybe 20 seconds or so. And you had to be super careful because that stuff, like
Yes.
if there's any curtains near it or other lights
ceiling.
too close, even the
Cobwebs
You
on
get
the
into-
ceiling will flash
yeah,
over.
yeah. So you had to really, know what you were doing and work with the venue to make sure like it was all totally safe, and work with the local fire department, send them a report and a plan of what you were doing. That's what I had to do anyway. But I remember, where was I going with that?
Well, I
There've
was
been
going to
some
say,
pretty nasty disasters. There was a metal band.
yes, there
not-
was.
I think it was in the early 90s or very
Loss
late
of
80s.
life. Yeah. Yep.
And yeah, a bunch of people died because the venue, that was in Boston, I think, and the venue.
It wasn't White Snake, but it was somebody like White Snake.
I think it could have been, or White Lion. It was one of the well-known bands. They had a very
Yeah.
crowded gig, good show, but the pyros set the stage on fire, and everyone panicked, and there was only one exit, and it wasn't
That's
big
right.
enough.
Right.
Yeah, so it's a shame.
No, I
but
did
the
all
cool
my
thing
pyro outside.
Well, the good thing is, all of these things are tragic, but the danger of these things sparks invention.
Yeah.
So lately, a couple of years ago at NAMM, a company released a new product that does the exact same effect, but it's non-pyrotechnic. And I think what they do is they actually have a flint stone inside and a motor driving a grinding wheel, and it fires little sparks up into the air, but you can put your hand in it and you won't even feel it. You just feels like, dust.
Right.
They're amazing.
Now, I road crewed one time for Brownsville Station. I don't know if you remember them, but they did, what was the name of the song? They had a big song here in the States. And they did a propane-based pyro. And, with a spark plug, literally, to ignite the pyro thing.
Yeah, those are cool. I experimented when I was doing that. I wanted to do something with nitrous oxide and butane. I wanted to rig up, and I played in my backyard at the time, trying to figure out how to do this. And I was putting a mixture of nitrous oxide from a whipped cream siphon.
Right.
That's the propellant for whipped cream, in case you didn't know.
Right,
And it's also a drug, people
happy
breathe
gas,
it in.
yeah.
Yeah, nangs. But I would squirt some butane from a lighter refill can into a balloon, just a regular party balloon.
Right.
Or actually, the little water bomb balloons, the small ones. And then I'd squirt some nitrous oxide in there and shove an electric match down into it and try to get it to seal. And they made this bright white fireball that lasted like, a few seconds. They looked so awesome. But the problem was I could never get them to seal up properly. Right. And I was worried that the latex of the balloon would carry on burning afterwards and cause hazards. So that experiment didn't work out. But totally non-electronics related. Sorry, everyone.
I have another story since we're talking about blowing up the backyard. In the old days, I used to mix potassium permanganate with glycerin, and it would self-ignite. So I took my mom's...
Yeah, that's how you make touch powder, right? Or is that Condy's crystals and glycerin? Or Condy's crystals, potassium permanganate's the source of a lot of different homemade...
It's an oxidizer. Yeah, it's an aggressive oxidizer. We used to be able to get it for pool cleaners. But so I put a little bag of the glycerin and potassium permanganate in the roll that holds the toilet paper for our house, right? It was 2 parts. So basically I'm making a pipe bomb. I just hadn't ever heard of the name before. Throw it out in the yard, and you shove it together to puncture the thing. 'Cause I had a little needle in there. Shove it together, threw it out in the yard. It blows up, blows a hole in the yard, right? And so I get in trouble for blowing a hole in the yard from my mother, right? And then like a day later, she's like, "Where's the roll from the toilet paper dispenser?" I'm like, "Mom, we've been over this. The hole in the yard, remember?" So I had to explain that that's what had made the hole in the yard was the paper roll dispenser tube.
Well, I'm happy these days to have fun with model rockets. I haven't done it lately enough. I need to go do a bit. That is still safe and allowed in the state of California where I live. And there's plenty of good rocket clubs and things around and wide open spaces out in the desert too, which are good for launching bigger ones. But one of the things that King of Random, God rest his soul, that was a tragic loss, but I discovered him through his YouTube video on how to make your own screw lock sugar rockets for model rocketry. That's a brilliant video if anyone's interested. He did a lot of really cool stuff.
Cool.
So
well, I have a rocket story real quick. So I took a carpet tube and I made an over-the-shoulder rocket launcher, but of course the problem with that is you get a face full of backblast when it leaves the tube. But that day, one of our rockets landed in the gutter of one of our neighbor's house. They had leaves in it, and so it's up there burning, waiting for the parachute charge to go off because it went way off course. And we set fire to the gutter, but it went out eventually. The leaves were wet.
You are so lucky, Bill.
Yeah, it was the 60s, late 60s, early 70s. It's
if a kid did that today, they'd be put in handcuffs for sure.
Yeah. But all right, on to electronics.
Well, there is a segue here that actually connects these topics. So when I was doing lighting and pyros, I designed my own triggering system because I didn't want to go out and spend thousands of dollars on the commercial pyrotechnics triggering boards that you could buy at the time, and they were just a lump of a steel box. with a row of buttons, but I knew how they operated. Being trained in electronics, they used capacitor discharge ignition to send a heavy current down the wire to the electric matches, because you could end up with quite a few matches in series and parallel. So they needed to have a decent voltage and a
like your car spark plug,
enough potential and a big capacitor to make sure that they ignited. And by the way, there's videos out there showing how you can make your own electric matches too, if you ever do get into pyrotechnics and want to do computer control. But that's a whole other subject. So I built my own capacitor discharge ignition board with a little locking key as well, so I could, walk away from it after everything was set up and know that no one else could trigger everything. And that was a really fun project. But that gets us to this topic of energy storage.
Okay.
And capacitors.
Love it. Great segue.
There you go.
So somebody in the Discord channel asked about, they saw various values of capacitors. And we use we stagger our values typically. And, I did the old rule of thumb where you use like 0.1, 0.01, you use decades apart. And we don't do that anymore. We get more scientific about it and actually look at how the capacitor works in a circuit, especially how it resonates or self-resonates. You
Right.
want to talk about how capacitors aren't perfect?
Yeah, they're not. That's a really good subject. So why do we have different values, and why do we have many different decoupling caps over the board? It used to be that printed circuit boards in through-hole days in the 80s, circuit boards were 2 layers or even just 1 layer, and you had to route power and ground to all the devices, and you'd have a ton of chips, in it, all lined up in rows and columns, and they were all like 7.4 series logic or 4000 CMOS. So they weren't exactly rocket fast devices. They were that technology at that time.
Right.
But to reduce power supply ripple on the power supplies and prevent false triggering in boards, it was recognized each device, or each 2 or 3 devices in the logic families, needed some local storage, local capacitance near the chips on the circuit board, so that when they were all switching together, there was enough energy to supply that current without causing a dip in the voltage or ripple noise, current noise in the power supplies in the surrounding PCB. So it became the rule of thumb to put a 0.1 microfarad capacitor for each semiconductor, each integrated circuit. You didn't necessarily need it for each transistor, but for each IC you'd have this one, and it worked. And it was not a scientific approach, it was an experimental approach, and it became the rule of thumb because it worked. But fast forward to the late 90s and early 2000s, and people are pushing chips up into the hundreds of megahertz clock rates, and there's all sorts of reliability issues, and printed circuit boards, packages got much denser. Printed circuit boards had to become multi-layered, and you'd have many signal layers, and you might have a ground and a power, and you'd put it in the middle of the board so they're close together, and call it good because you think there's going to be plenty of extra capacitance between VCC and GND in your planes, and then you still have this 0.1 microfarad per power supply pin kind of deal going on with bigger ICs, and it's still not working properly. And so, the smart people in the industry are actually the PhD guys like Eric Bogerton, and the seasoned experts who really understand signal integrity, like Rick Hartley,
right?
Did their actual research and said, you're putting all these capacitors over the board, but at what frequency are they actually running? Because these capacitors have leads and metal, and any kind of conductor has inductance as well. So you have all these in a multi-layer ceramic chip capacitor. I don't know if you could bring up a screenshot of a multi-layer ceramic chip of the insides of it, but you could just Google that.
Yeah.
You
okay.
see
I was going to say here's what we had before MLCCs, and these were just horrible. The old-fashioned wax dip caps.
Yeah, and they were fine. They were fine in the 80s because the lead inductance didn't matter then. We weren't running that fast, and but even now with an 0402 tiny little 0402 0.1 microfarad capacitor, there's a heck of a lot of lead inductance, right? Yeah, so there's the image. So it's made up of layers, so you get that plate capacitance, but going into and out of that you have, and distributed throughout it, you have a lot of inductance as well. And so capacitors aren't only capacitors. They have DC resistance, they have conductive,
leakage.
They have leakage, so it's, and they have dielectric loss, which appears as the G term in RLGC sort of lumped elements, but it's dielectric loss, but it is effectively like DC resistance in what it does, although it can change with frequency, so it's not exactly like normal DC resistance. But and there's lead inductance that's in series with the capacitance. So the capacitor behaves mostly like a capacitor until you get to some sort of frequency where that inductance becomes a problem. And you were showing a data sheet or an app note there from AVX. So what's that we're looking at there, Bill?
So this one is, let me go down to, on the right, you can see that these capacitors have a frequency response based on, on frequency and based on the value they are. So it's a tank circuit that it's called self-resonance due to its own self-inductance and its capacitance. And what we see is that the resonant point is different based on the value. And this is one of the reasons we used to stagger it, is if all these dips, appeared in the wrong place, they wouldn't help us as much as having them spread out like this. Right.
So you can see, and this looks interesting because they show the 1 microfarad capacitor as having a much lower impedance.
Right.
Certainly at low frequencies, that has to be true because the reactance, which is like the AC resistance, or it's the impedance, not taking into consideration the inductance and resistance. But if you only look at the capacitance, impedance is reactance essentially, and the reactance is that slope downwards towards that resonant frequency at the bottom of the dip, and so it's more capacitance, and reactance of a capacitor is inverse of frequency. So as the frequency goes up, the reactance or impedance of the capacitor should get less and less and less, and the more capacitance there is, the lower the impedance. But the problem is that lead inductance kicks in after that. So after that resonant peak or trough, let's say, the capacitor actually behaves like an inductor.
Right. So, and then there's something we only started looking at, which was the anti-resonance point, and I want to see if I can find a good picture, because in the old days, we would see just this dip here of low impedance.
Yeah.
But if we go up in frequency, we find right behind it's a real high impedance. It's almost useless at this point. And then I would argue that you can get some oscillations and some tank effects going.
You get ringing, yeah,
ringing.
That's nasty. But wait, does this happen when people join multiple values and stagger them, but don't do it carefully or scientifically? Because
go ahead.
Go ahead. No,
I was going to say, there's a spreadsheet that Lee Ritchie put us onto that allowed us to plot and overlay these, and it's an Excel spreadsheet. Hang on, let me pull this out of my way.
Ooh, where can we get that? We need to post the link to that in our Discord so everyone can get access to it.
All right. I'll try and dig that out because I almost did a Hackaday thing on it and just ran out of steam before I was done. But it allowed you to move them by picking different values, and it would actually use the Excel plotting function to draw these, and you could see the overlays in real time in Excel, and it was great. And Lee said that's what they still use to this day as one of their preliminary simulations is Excel.
And something I'll note, I'm not sure if it was AVX or one of the other cap manufacturers I was looking at recently. Who was it? It wasn't Weimer, but
Murata,
I think it may have been AVX, but you can actually, from their website, they have complex simulation models, SPICE models for their capacitors.
Yes, they do.
So you can actually put. So what they've done is they've gone into the lab and measured. They've got a new family of caps in a certain package size. They go into a lab, they measure 100 of them or whatever, average out all the accurate results of the batch, and they know the extremes and they know the normal, median, and average performance curves. So they measure the impedance over a broad frequency range, and they curve fitted that data into essentially accurate SPICE simulation models. So you can download the cap model and don't use the built-in SPICE generic capacitor, which is kind of ideal. That's good for learning circuit theory in a classroom. But if you want to actually get an accurate simulation of how your circuit's going to perform, you get these realistic cap models, and you can put them in parallel, the different values, and use the real models, and then have a switching load set up in SPICE. And so, I can go into Fusion 360 or Bil use LT SPICE. Any of these tools will work with these models because they're proper SPICE 3 models. And you can actually measure it and see, well, at the load frequency that I care about, because my microcontroller is doing some heavy computation and it's running at 300 megahertz, say, internal clock. How is that switching load going to, what's this actually going to do, with this transmission line element from the load to the storage cap, which represents a little bit of printed circuit board trace, and then my transmission line element to the main battery or power supply, which is considered an ideal source at that point. But you can actually see current resonances and ground bounce and all sorts of things. Yeah.
Right. And that's done with S parameters, right? Or that's one of the ways that they'll model it, or make it into a black box that you can add to the simulation.
Right. And I think most generic SPICE simulators, I could be wrong here, but I believe generic SPICE simulators out of the box don't use S parameters for simulation, but you can convert an S parameter data set, which is what you measure. So you can actually get a TDR, you can put your device in a test circuit, you can measure it, and then what you can do is you can de-embed, which is a whole other topic for another day.
Right.
You can de-embed the test jig and cables so that you just have the piece that represents the part you're measuring, and your TDR you can save the S parameter file from that. Then there's software that will convert the S parameters to a SPICE model, and that's typically a part of very expensive SI tools like SciWave from Ansys, right? They have tools for that, and you pay for it because there's a lot of engineering that goes into that kind of software to make sure it's accurate.
Right. But you can also do transistors and other things too. It's not just capacitors. You can model. You go measure an RF transistor and drop it into your simulation, and it's like it's more empirical than a bunch just estimates.
That's right. So if you're doing RF circuit design, especially, you want to use the manufacturer's model because it's going to be, and a lot of, particularly for RF active devices like transistors, the manufacturers that make those parts provide S parameter files for those too, which you can use in other software. You can even use S parameter files. Cooks and other free tools will read those in, or you could even do it in Excel I haven't bothered to do this, but S parameter files are just text files that represent the S parameters.
Right.
The reflections and the transfer characteristics. So what's that you're showing me there, Bill?
I just happen to have an RF book. We all know mini circuits, but this happens to be Macom. It's a good maker of RF stuff. So I just happened to trip across this, and I just love RF books. You can, just by reading a data book, which I know they don't have data books anymore, you can learn so much.
Yeah, because well, let's put it this way: the real experts, to a degree, in those fields are the people who end up working for the companies that design and manufacture those parts, because you have to have that knowledge and skill to make parts for that industry. And so they're either applications engineers or they actually become the semiconductor designers for those companies. So then it's in their interest to teach you how to use their parts. So in doing so, they're also teaching you a bit of the theory, which is really good. So app notes are always good. So you're showing printed circuits handbook. That, I'll tell you what, Clyde Coombs did a major service to our industry by producing that series of books.
Yes. Yeah. I just happen to have a bunch of books laying around, and the first thing. Hang on, I'm doing some things in the background here. But the first thing Ben did was pull it. This is a third edition from the 80s, and Ben pulled out his edition. What edition did you have?
I have the 50th anniversary. I believe it is the current one, and I don't know if there will be another.
Here, let me bring you up. I got the chat to working again. Let me bring you up.
6th is still fairly accurate, even 5th and 4th. Even the 3rd, essentially most of this doesn't change. They just keep adding chapters because there's new technologies that keep coming out. So How thick's yours? Can you put it sideways?
Yeah, so what you just said is true. It's about 3/8 of an inch, half an inch thicker.
Why would you recommend getting a copy of this book? It's pretty expensive. The new one is, anyway.
Well, back in the day, I just read everything I could. So, and I needed a reference. There was no internet when I bought this. So this is how you had to have a library of reference material if you wanted to solve problems you didn't yet know the answers to. So you couldn't Google for, and matter of fact, I just happened to open an IPC guide, and this is a beautiful picture.
I had a poster of that one. It just lists all the problems that can happen in production with holes, with vias. Yeah.
Okay, tell us what IPC is.
IPC is an industry standards body, really, but it's an industry association for anyone involved in printed circuit board manufacturing mainly and assembly. It used to stand for something like International Printed Circuits, or whatever, but they've changed it over time, and I don't remember what it's called now.
Yeah, I don't remember either.
They essentially got together in the late 60s as printed circuit boards was a really burgeoning industry and taking off. They said, ooh, we need to start building some standards around this so that we can support the creation of new fabrication and assembly houses, and so that people do things right and safely and in a way that protects as much as possible the environment. Because PCB manufacturing is about one of the worst environmental things. It has been historically.
Yes, yes. It's illegal in New Jersey to have a PC board house or a chrome plating house. They're not legal here.
Wow. Yeah, because these some of the worst chemicals on the planet. But having said that, with modern fabs, like the absolute cutting edge ones, some of them have zero exhaust. They're expensive to use, but it's everything when it's new and cutting edge is expensive, but eventually becomes normal. So that's the goal, right? And there are fabs that claim to have no exhaust but H2O. They probably have some carbon footprint, but
Yeah.
because they use energy, right? But they can re-extract all the unused metal. They can re-extract all the unused carbohydrates from the polymers. The one that, no, I guess they could reuse the glass even too. I don't know. I've been told by those people that they have their only exhaust is water. It's hard to believe, but I think it could be possible. I think it's plausible.
So yeah, somebody asked if MOS screwed up the groundwater, and we absolutely did. That's part of the legend of MOS. Is the day I pulled up there for my interview actually. They had sprinklers going, and they were aerating the groundwater that they had polluted. It got classified as, I don't want to say a super site, but it was something similar to that, and they ended up having to pay for like 12 people in the area to hook to city water. There was also a creek involved, I'm told.
That reminds me of what was the city? Detroit. There's a burning river.
Oh, yeah.
A burning river in Detroit. So the factories got so careless with just dumping crap in the river that the river actually caught on fire more than once.
Which means that there was an ignition source, and it'd be interesting if the ignition source was the river itself, or somebody, was it the chemicals actually spontaneously went, or did a motor or something set them off?
Yeah, who knows? Oh. I'm
so
just
anyways,
glad that we're a lot cleaner than we used to be, and I'm glad for that.
Yeah. So I thought I'd show this, though. This just happened to be I'm moving piles of stuff around, and in here it actually showed, I probably won't find the page again, it showed all the different IPC standards for like lead versus non-lead. Matter of fact, here we go.
Yeah.
Choice of printed circuit material, designed for cooling, footprint land. It's a standard for land shapes. It's the wetting of the board.
Those are the ones that we care about, right? As engineers and designers, most of the IPC work is really around fabrication and assembly and the people running the factories. But for us as designers and engineers, there's really a few that we care about. There's IPC 7351. That's the land pattern standard, they call it. But that's the one that helps define the standard for footprints in your CAD library to make sure they match. And what's really frustrating is that IPC defines everything about the board itself and its documentation, but the actual packages are we refer to them by the actual package name, and that doesn't come from IPC at all. That comes from JEDEC, a completely different standards body for the semiconductor industry that defines the actual lead frames and plastic molding of parts. So that they're the ones responsible for the dimensions of an SOIC 8, and the IPC Land Pattern Center refers to it SOIC 8, but it's really annoying because all the manufacturers of the parts have their own internal naming conventions they use. They refer to the JEDEC standard, but there's no like one place where the JEDEC standard, the manufacturer's package name for that part, and the IPC standard are all linked. Like that's left up to you, dear designer, to figure out in your library, and it wastes tons of time.
Yeah.
Sort of, this looks like a SOIC, but they're calling it an SOP. I'm not sure. Like, what the hell is this thing? Is it an SOP? It is is it an SOIC? And the best you can do is just read the data sheet and enter the dimensions directly into the wizard and let the software build a footprint for you that's accurate. So anyway,
I just made a footprint mistake the other day for somebody, and it was supposed to be a 1206 or a 1210 cap, and it was mislabeled in my library, and I had the wrong size cap, and I would never have caught it unless I sat there and actually did something in scale, because you see it on the screen, and unless you see something the size of right next to it, I just missed it was the wrong size. And I to this day don't know how it got in my library. Obviously it was me that did it, but how the heck did I get it that wrong?
That's the other thing that I hate is that I've already mentioned IPC with the 7351 standard, and JEDEC with the JESD 95 is a series of standards that gives the actual 2D drawings of standard packages, right? And you can download that one for free. You just set up an account at JEDEC, and you can get those. But then there's the manufacturer data sheet. But you just mentioned something that made me think there's a fourth standards body here, which is the Electronics Industry Association, that's now part of what's it called, ECIA or something like that. All the distributors like DigiKey and Mouser are members of this organization, and so they have this fourth group that defines standards, and they're the ones that came up with the naming for standard part types for all the popcorn components. So you refer to a capacitor decoupling cap as being an 0402,
right?
Or a 1206,
right?
Who came up with that? That was the ECIA that came up with that.
Okay.
That organization made up of all the distributors.
I didn't know that.
And that's just really, it's just so daft. It's so annoying to have different sources of information and not just one central source of truth to refer to. But they did this really, really smart thing, and they said there's a Imperial size code, which is the length and width of the chip component in
millimeters or something.
It's in tenths of an inch. Tenths of an inch.
Okay.
That's the Imperial code. And it has an equivalent code in millimeters, or, and so
submil. Yep.
There's an 0603. Now, when I say 0603 and you say 0603, we're probably referring to the Imperial size code, which means it's 60 mils long and 30 mils wide, mils being thousandths of an inch. Right. But it has a metric size code, which is 1206, because it's 1.2 roughly by 0.6 millimeters. Yeah, that one.
Yeah, let me see if I have to pull it to the top.
Yeah. But this bites people in the butt constantly. I had a very upset PCB designer who had gotten in trouble with his boss because the parts that were on the bill of materials were far too big for the LAN patterns on the board, and he thought he was using an 0603 part from our library.
Right.
And this is back when I was at Altium, so we have all these parts in the library, like Eagle does too. Like every good CAD tool comes with a bunch of parts you can use. But the parts were named, like with the footprint, 0603 and then in parentheses 0201, meaning this part
it was metric, yeah.
is 0.6 by 0.3 millimeters. It's not 60 by 30 mils. It's a different size part. It's actually an 0201 by the Imperial code. And the guy's like on a Zoom call with us, well, it was GoToMeeting at the time, saying, I don't understand. This is an 0603 part, and I bring it in, and now it's actually far, far too small. This library content is wrong. It's bad, and we made bad boards, and I'm in trouble for using your library, and I can't trust it. And I'm like, are you talking Imperial or metric? Because that is an 0603 metric.
Metric,
and he's
right.
like, oh,
yeah.
Oh, I misunderstood that and I didn't check it. And it's like, number one golden rule of PCB design, always do a check print to actually measure or use the tools in the software to actually measure the scale of the parts and make sure, yes, do it. This is why we do design reviews. So this kind of crap doesn't happen. But every experienced PCB designer has probably, whether they admit it or not, they've probably had that issue at least one time where a part just completely didn't fit the footprint that they had for it.
Right. And 0603 is notorious because it's a size in both of them, whereas if you see a 3225, that's metric.
Hey, Mike's sharing us. I just want to point this out. Thanks, Mike, on the the Discord. This is one of the purposes of these beautiful rulers that we get at trade shows, right?
Right.
Rulers from I have a Euro Circuits one here, and this one doesn't really have a lot. It's got different hole sizes and trace widths you can measure, and that's on one side. It's got current ampacity. That's not particularly useful, but the one Mike sent a picture of, it's more like the DigiKey ruler that has a few different footprints on it. Let's see if this one has. This one's just marketing. I don't have a good one. So Mike, Bill, I don't know if I can share my screen real quick.
Yes, you can.
I'll show you what Mike was posting here. Let's go. I'll share the Discord. So I'm sharing that on Skype.
All right, let me grab it. Which requires reading glasses.
This is a very valuable tool, and even if you don't pick up one of these rulers that has this from a trade show, it's probably worth making one. Just design one in the software and have it made by Oshpark or whoever. It's worth the investment. It won't cost you much. But this is a really useful tool for checking actual part sizes against something real. So what Mike's showing us here is this ruler has the Imperial code next to the metric code in parentheses. Right, so an 0402 in Imperial is a 1005 metric because it's 1 millimeter by half a millimeter. A 0201 Imperial is an 0603, so 0.6 by 0.3 millimeters. Those are really tiny. I don't prototype with them by hand at all. I can barely get by with 0402s. But if you ever hear me say 0603, I'll just tell you now, even though I grew up in a metricated country, I'm from a metricated country. And when it comes to PCB design, I still mainly think in mils because that industry was stuck in mils for the longest time, and that's just how I think of it.
Yep, so. Same here. So, and the other thing, I had to teach my son, I accidentally bought some 1210s. And I'm sorry, we stuffed some 1206s onto a part that called for a 1210, and it worked, but you could see there was too much solder paste. And I had to show them how during inspection to look under there, and you could see the balls, and that told you, oh, it's the wrong size part.
Yeah. Yeah.
So, yep. I've made my share of size issues, and it's usually, like I said, I have to stop and go, am I metric? Am I imperial? Am I, yeah. And it's harder as my short-term memory gets worse, or as my memory, while I'm working. But for me, the main thing is I don't work enough in the PC board layout phase where I've got automatic scale when I look at it. I have to like zoom out. It's like I wish I could have a virtual dime or something I could put on the board and tell me, because you zoom in, it looks the same size whether you're wrong or not.
Yeah, maybe it's helpful even while you're working in the PCB design software to
use a ruler.
I'm getting a meeting reminder.
Your audio broke up as soon as you got the meeting reminder. I lost you.
Yeah.
So,
but I think that would be a great idea to have some kind of actual scale represented in the PCB design workspace. And you could make a thing to do that. You could draw it.
You could, yeah.
Just make it part of your template. That would be one way of doing it.
So an Altium trick I had to find out the hard way was when I tried to measure an Altium, the width of the lines were so huge I couldn't see what I was measuring of the arrowheads and the lines. And you had to go into preferences and set the width for when you're measuring. And I can't begin to remember where it's at.
I think you're actually confusing measure something with dimensions, because a dimension is an object drawn with regular PCB editor things, and we have the same in Eagle and Fusion. You can place dimensions in the actual PCB design, which is very useful. But they have a kind of default line width and text size, and you can go into the inspector and change all of that.
Right.
Or modify it as you're placing it. A little window pops up and you can modify that. But I prefer those because they stay and they're static, but there's a separate tool which is just like a ruler tool. And again, both CADs have it. You can just click between these two different things and it'll tell you the distance. That's super useful if you just want to quick measurement of something. But I'm just thinking, I might set up my default settings to always have a little ruler in the corner near the origin for scale reference. I don't know. I'll have to try it and see if I find it useful, if I'm actually referring to it, or if I find it annoying. Right. It's hard to know until I try.
So also from this pile of stuff I found, or that I was just moving, I know you're a big fan of Sierra Circuits' DFM stuff, and I just happen to have a printed one. This is another document that if you're into this stuff, I recommend Google for it and find it.
Excellent. Yeah, well, just go to, you can go to sierracircuits.com or protoexpress.com is their other URL. And they have all these guides like this that are super, super useful. Of course, it's their content marketing. But these are technically very well done guides that make it really easy to understand the issues around DFM for PCB and what they help you design. They will help you build your default design rules when you're doing PCB layout.
Right. And they probably have an online. Do they have an online DFM checker? A lot of people have those as well.
They do. Most good PCB fabs do now, but Sierra was one of the pioneers for online calculators and testers, checkers for things. Yeah, they do. So you do have to sign up, and that'll put you on their marketing list. But I would say it's one of the ones that's actually worth signing up to get access to some of their tools. Right. They're very cool.
So this reminds me of the time you and I were talking about teardropping. I think, can you see this on the screen?
Yep.
They show.
Yeah.
So you had reminded me that teardropping is prevent breakthrough in the one direction that the signal comes from. And that it took me like the rest of the day before I remembered that we used to have a manufacturing rule that says if you break out anywhere, throw it away. So in my mind, it didn't matter which direction it broke out in. But teardropping absolutely prevents it from, or not prevents, but helps to prevent it from breaking out in the signal direction.
Yeah, and there's actually 3 different, like, this is one of those IPC standards that you learn about when you're, like, so I am a CID plus certified PCB designer. I did the courses and exams to get certified. So that's one thing that IPC does, is they also provide industry certifications to show competence in different areas. Again, mostly around manufacturing, and the designers are considering separating that out and just doing something dedicated to design, because it's a bit broader and deeper than some of the other things. But in doing those courses, which I highly recommend if you ever get a chance to, they're very valuable.
What's the name of the courses again? Say that again. What's
CID, Certified Interconnect Designer, or CID Plus, which is Advanced Certified Interconnect Designer. They're well worth doing, because even if you're an electrical engineer and you can read all this stuff and find it, and you can find your way just fine, but it's like a condensed, practical, this is how boards are made, and these are why problems happen, and this is how you document everything thoroughly and properly, and design things properly, and specify DFM rules properly, so that you don't have these problems and you can get things right the first time much more often. It's very worthwhile. But there's, along with that, you get some of the standards, and one of them is the design standard, and it talks about breakout, and there's these different producibility levels. So it's a matrix of, is something very, very complex using cutting edge manufacturing technology? Is it very basic, or is it moderate, or is it very, very simple, like a basic 2-layer board with, big clearance and wide traces and simple stuff,
Right.
Right. And then matrixed against that, they have producibility levels. Is this
what's the fallout going to be?
3 producibility classes, and matrixed against that, so that's how hard is this thing to make, and matrixed against that is how accurate or what quality level do you require from this, which depends on industry. So if you're designing a board for aerospace or automotive is the hardest. It has to be bulletproof, and so you have to be very strict on DFM, and you can't allow things like breakouts. But the example the instructors use in the course is a good one. If you're doing a simple phenolic board for a gift card that when it opens it flashes some LEDs and plays a tune,
right.
A bit of breakout here and there it's still, as long as it connects, and the only thing is, does it work? Right? If it works, no problem. We're okay with that. So you can allow these things to an extent, as long as the plating still made it through,
Right. So and yeah, that's kind of where I ended up by hook or by crook, was in the real high production. As a matter of fact, we were just talking yesterday and realized that the TED computer that I worked on, which is called the Plus4, the 264, they ended up making 2 million of them. And I thought it was somewhere around 800K, but by the time you take them all into account, it was 2 million. And we called that a failure, by our standards, of 27 million for the C64, it was a dud.
Oh my gosh.
So
I just can't fathom how successful and triumphant I would feel having anything made, even in the hundreds of thousands. But, I'm probably giving away too much.
So, by the way, we talked about vacuum fluorescent last week.
I love it. It looks so good. So you just driving that with an Arduino or what?
Yeah. Yeah, I just grabbed the Arduino and used the regular LCD. It turns out it's the same Hitachi driver on there, Hitachi. And and I'm not a coder, so the fact I was able to get it working in an hour shows how straightforward it was.
Fantastic. So you're using the 4-bit parallel mode?
I am.
Yeah.
Yep.
That's the good thing about those. They never did take up too much IOs on your, so you can use them with a small micro. I like them a lot. That looks really nice.
The only thing I had to do where it didn't power on the first time was I hadn't grounded the write line. You know, I'm used to a dynamic write line. And I look at it and realize, whoop, there's a chip select, there's a read, you know, and I ground the write line and it came right up. Yeah. Register.
What's it look like without the gel emulsion filter in front?
It's mostly, you're going to get glare.
Yeah.
But to me, it looks very clear. It just doesn't come through in the camera real well.
I see, yeah.
So the filter was more for the camera's sake than anything.
Yeah. Makes a big difference, actually, for the camera.
Yeah. Yep. So, all right. I'm running out of things to talk about. I have a pile of papers here. Oh, here. So I'll pull out one more. If people are looking for good references, here's one for you.
SI Journal, and that's a free one, too. That's a good one to get.
You can get it off their website. They can email it to you, and they don't do a ton of the follow-on marketing. You know, where if you send them, if they have your email address, they won't spam you. Is what I'm trying to say.
Well, the point is, it's motivated by the instrument manufacturers, and they sell very few, but at a very high price. So that's
yes,
the
they
business
do.
Model, and you can learn a lot about instruments and how to measure things in there, and then you'll just want to go get your hands on one and realize you've got to come up with a lazy $200,000. Gosh, I saw TDRs once at a semiconductor company I visited. I won't say who they are, but they're really big. And the guy I was talking to was using TDRs that were the main unit was $700,000 a piece.
Wow.
Yeah.
Wow.
And he had like 4 of them because he had to do multi-input, multi-output tests on cutting edge interfaces from a DSP or microprocessor or something.
Yeah.
So, yeah, it's like
the kind of equipment you'd marry. Yeah. Yep. So I think Eric Bogatin is one of the primary editors of Signal Integrity.
Yes, he is. And he is such a generous soul. That guy has done so much for our knowledge in the industry. It's incredible.
Yeah, and it's got articles about like the truth behind connector design. We don't often think of how important it is to design the connector for high speed, because that's something we have to live with. You pick a connector. And so the guys, what I see in this SI field is a lot of them are connector people.
Yeah.
Sam Tech and those guys. Yeah,
that's right. Yep.
Heroes.
There has to be. See, the connector has traditionally been the problem with high-speed signaling. If it's chip to chip, then it's the pins and that was pretty well solved by shrinking everything down to BGAs and being able to surround a signal pin with ground pins or balls under the device. And so on a board, it's less of an issue, but the problem is you need 8K 3-dimensional video, don't you? So how do you get that from your device that streams the media to the display? That's right. What we're talking about here. That
right. Or how do you get from board to board?
That's this thick.
Right.
Not easy.
Well, we're coming up on the top of the hour here. Any last words or anything? I mean, we went through a pile of papers here, some cool stuff. I learned about CID. I did not know about that, actually. About CID testing.
The CID, yeah, I'd recommend it. If you want to get a job or even contracts as a PCB level design engineer, it's worth having CID at least. It shows that you're very aware of what fabricators do and what assembly houses do, and the kinds of problems they have if a board isn't designed properly for manufacturing. And it helps you also learn all their lingo, which you need for when you're negotiating with them. And
how many hours would you say it took you to complete the material? And
there's for CID, there's quite a big study guide, and there's a 3-day class, and I recommend you do the class. Well, you basically have to do the class, and the third day, second half, is the exam, where it's proctored by the actual instructor. And so but before you do the class, you sign up for it and give yourself at least 3 months for reading through the study guide first.
Good advice.
Just you don't really have to take notes on the study guide while you're doing that, but you do have to read it and read it thoroughly. And then after 3 months, you take the class, you discuss things, you bring your questions to the instructor, and then you do the exam. If you do that and you already know electronics and you've already designed a board or two, you'll pass, no problem. But it's a worthy qualification for anyone who wants to get paid to design boards, which, it's a fun thing to do, and it pays well. Even if you're just a contractor, it can pay well. And then CID Plus just goes into more depth into DFM, and it covers more advanced topics, and that's a 2-day class with an augmentation to the other study guide. And again, the way that they run the exams, they usually schedule them so that they're 6 months apart. So you could do one and then do the other 6 months later.
Okay, good to know. Good to know. So, I have another teleconference coming up, so we got to land this ship, as we say.
Hey, it's been great, and I'm glad that we got the stream going and everything's working well, and I really look forward to doing this with you again. And everyone, just a reminder, please subscribe to Bill's channel on YouTube for this. Go to the Coriolis-effect.com for news. It's just a simple site, but that's just one place where we're going to be posting.
And Discord.
And
can we put the Discord QR right in one of these windows, I wonder?
I would say there must be a Discord plugin for XSplit that we could probably figure that one out.
You'd think, wouldn't there? You'd think.
So if you're watching this, the Discord link, we'll put that's on the Coriolis-effect.com. The Discord link is there as well. If you want to click on that, you can join our Discord. Or search in Discord. You can search. It's the Coriolis Effect Tech Talk with Bill Hurd and Ben Jordan. That's the name of the server. If you want to do a search and find it that way, Coriolis is Coriolis.
And Bill is BIL, 1L.
1L.
Which I accidentally made a good handle. Yep. Hey, so good talking with you, my friend. We will see you next week.
Hey, good to see everyone too on the chat there. Catch you next week.